to determine the eigenvalues and eigenvectors of a matrix. Now, let's consider a matrix A, the introduction to eigenvalues and eigenvectors. Let's consider a matrix A, which is a n by n matrix. Now, and if lambda is a scalar, then x is the non-zero vector. So we can write ax in terms of lambda x, and our x is what? Is a non-zero vector. The scalar, after getting the value of scalar, we can get the corresponding values of what? Of our eigenvector. And the eigenvector is what? The vector is what? Is a non-zero vector. So you should not get 0, 0, 0 in your what? In your eigenvector. So now, there's something we call the characteristics equation. The characteristic equation is the determinant of the matrix given to us, matrix A. Let's say this is matrix A. Any matrix, that's A minus lambda I. That's this lambda is what? Is the scalar. That's the eigenvalues. And this x, the x is a non-zero vector, which is the eigenvector. So the determinant of A minus lambda I is equal to what? 0. That's the characteristics equation. That's how to get the eigenvalues. Now what about how to get the eigenvectors? We take A minus lambda I. This is the identity or unit matrix. If it is 3 by 3, the identity matrix should be what? A 3 by 3 matrix. So A minus lambda I x, that's the variable, equal to what? 0. That x is a vector. Depending on the number of variables, number of columns gives the number of variables. This x is what? Is a vector. Now, how to determine the eigenvalues and eigenvector? For you to determine the eigenvalues, we need to take our characteristics equation of this. That's A is this, A minus lambda I. Lambda I is, this is I, that will be 1, 0, 0, 0, 1, 0, 0, 0, 1. So when I say lambda I, that means this becomes lambda, and this becomes what? Lambda. So A minus lambda I, that gives the determinant of A minus lambda I. That's 1 minus lambda, 0 minus 0, 2 minus 0, 2 minus 0, 1 minus lambda, 0 minus 0, 2 minus 0, 0 minus 0, 1 minus lambda. So that's this 2 minus 0, this 2. So that's 1 minus lambda is 0, 2. 2 minus 0, that's 2. Then 1 minus lambda is 0, 2, 0 minus 1 minus lambda. So we take it as what? 0 to get our eigenvalues. Now, how do you find the determinant? This is a 3 by 3 matrix. Evaluate the determinant. Let's use the what? The first row. We're using the first row, that's plus, minus, plus, to evaluate 3 by 3 matrix. So that will be plus 1 minus lambda. Then the determinant of 1 minus lambda is 0, 0, 1 minus lambda. Then minus is 0. That's 2, 2, 0, 1 minus lambda. All this would be what? 0. Plus 2. 2, 2, 1 minus lambda is 0. So that means 1 minus lambda, then 1 minus lambda all squared. This is 0 plus 2 is 0 minus 2, 1 minus lambda is equal to what? Is 0. Now from here that gives 1 minus lambda and 1 minus lambda all squared minus 4, 1 minus lambda equal to what? Is 0. Now 1 minus lambda is a common factor. We take it as 1 minus lambda all squared minus 4 equal to what? Is 0. Now here we take 1 minus lambda equal to 0. Don't forget it's a 3 by 3 matrix. You need to get 3 eigenvalues. So 1 minus lambda equal to 0 and 1 minus lambda all squared minus 4 equal to 0. From here, lambda is equal to what? 1. And here, 1 minus lambda all squared is equal to 4. 1 minus lambda. This is what? A quadratic equation. So you are expected to get two different roots. So if you take the square root of both sides, so you should get a what? A plus or minus square root of the right hand side there. So that's 1 minus lambda is equal to plus or minus 2. So that means 1 minus lambda is equal to 2. Then 1 minus 2 is equal to lambda. Lambda is what? Minus 1. Also, 1 minus lambda is equal to minus 2. 1 plus 2 is equal to lambda. Lambda is equal to 3. So the values of the eigenvalues are lambda is equal to minus 1, lambda is equal to 1, lambda is equal to what? 3. Now there's something you should note. You want to check if your eigenvalue is right or not. Now the sum of the eigenvalues of a matrix is the same thing as the trace of a matrix, and the product of the eigenvalues is the same thing as the determinant of a matrix. Now let's just check for the sum of the eigenvalues. Look at the eigenvalues. What is the sum? Minus 1, lambda 1 plus lambda 2 plus lambda 3. That's minus 1 plus 1 plus 3. What is the answer? That's what? 3. That means the trace of the matrix should be what? Should be 3. What is the meaning of the trace of the matrix? The trace of the matrix is the addition of the main diagonal. This main or principal diagonal. The addition of the diagonal. The main diagonal. 1 plus 1 plus 1. That's 3. So the sum of the eigenvalues is also what? Is also 3. So that's how to get the eigenvalue. So how do we generate the eigenvectors of the corresponding eigenvalues? Now note this thing. If let's say after finding the values of the lambda, let's say we have lambda is equal to minus 2 twice and lambda is equal to 1. That's minus 2, and 1. This minus 2, the eigenvalues you have to get here, the eigenvectors you have to get here, you have to get two different eigenvectors. If lambda is minus 2 twice, doesn't mean you have to get the same eigenvector. You have to get two different eigenvectors. Now how do we get the eigenvalues of minus 1, 1, and 3? To get the eigenvectors, that will be a minus lambda I x, that's the vector, equal to what? 0. That becomes 1 minus lambda is 0 to the same thing without the determinant. 2, 1 minus lambda is 0, 2 is 0, 1 minus lambda. Then x. Now, how many columns? 1, 2, 3. So that's 3 variables. x1, x2, x3 equal to what? 0. Just like in all space. Now, when lambda is equal to what? With anyone. Let's start with minus 1. When lambda is equal to what? Minus 1. Well, what will be the corresponding eigenvector? When lambda is minus 1, the corresponding eigenvector. Now when lambda is equal to minus 1, that gives 1 minus minus 1, that's 2, is 0, 2, 2, 2, is 0, 2, is 0, 2. 1 minus minus 1, that's 2. So x1, s2, s3, that's 0, 0, 0. Now this is 2. Before we find the value of x1, s2, s3, remember from null space, we need to reduce this matrix to what? To a row echelon matrix. But the pivot here is not 1, it is 2. So our row 1 new becomes 1 over 2 row 1. That becomes 2 over 2, 1, 0, 1, 2, 2, 0, 2, 0, 2. And we put x1, s2, s3 equal to 0, 0, 0. Now how do we reduce this what? Row 2 to what? To 0 with respect to row 1. So our row 2 rather becomes row 2 minus, this is 2. Look at this here, this is 1. That means 2 minus 2 times 1 will give me what? 0. What about row 3? Row 3 minus 2 times what? Row 1. That gives 1, 0, 1. 2 minus 2 times 1 is what? Is 0. 2 minus 2 times, that's 2 minus 2 times 0, that's 2. 0 minus 2 times 1, that's what? Minus 2. So root 3 is what? 2 minus 2 times 1 is what? Is 0. 0. 0. This x1, s2, s3. Now the pivot here is not what? It's not 1, it is minus 2. So we can still divide our row 2 by what? By 1. So row 2 by 2 rather becomes 1, 0, 1, 0, 1 minus 1 is 0, 0, 0. Whenever you are finding the eigenvector of the matrix and you reduce your matrix to row echelon, your last row here will be 0. Now how do I get the eigenvectors now? The eigenvectors 1 times x1 is 0 times s2 plus s3 is what? Is 0. 0 times x1 plus s2 minus s3 equal to what? Is 0. Now because I said there's something we call pivot and free variable. The leading element, the pivots are the leading element, x1 and s2. Now the free variable that can take any value is what? The other variable left behind, s, which is s3. Pivot is leading s2. Now free variable will take any value. Just say let s3 be what? Be k. So if s3 is k, that means s2 is what? Minus, that will be plus s3, that's k also. Now what happens to x1? x1 becomes minus s3 minus k. Minus k. So the solution will give x1, s2, s3. That's x1 is minus k, s2 k, s3 is what? Is k. Factor out k, that's minus 1, 1, 1. So when we take k as 1, not because there is 1 here, just take k as 1, then the eigenvector, the first eigenvector, of what? When lambda is what? Minus 1 is minus 1, 1, 1. Now also we get the eigenvector when lambda is what? 1. Also when lambda is what? 3. Now how do we get the eigenvector when lambda is? You can pause the video and try to find the eigenvector when lambda is what? Is 1. So when lambda is 1 now, 1. So this gives 1 minus 1 is 0. Is 0. 2. 2 is 0. 0. 2 is 0. Is 0. And this is x1, x2, s3 is 0, 0, 0. Now look at this one. 1 minus 0, 0, that's 0, 0, 2, 2, 0, 0, 2, 0, 0. Now this is not a row echelon matrix, but we can just multiply without reducing the matrix. This is not a row echelon matrix. No pivots. This is not 0 and there is 0 here. So it's not row echelon. Okay, 0 times x1, 0 times s2, then 2s3 equal to what? 0. I can still divide my s3 as what? My x1 as what? I can divide this row 1 rather by what? By 2. Okay, that's 0x1, s2, 2s3 is what? 0. That's 2x1 equal to 0. And also 2x1 equal to what? 0. Now remember your vector is a non-zero vector. Note. Now this is 2x1 equal to 0. For me, that means x1 equal to 0. 2x equal to 0. That means s3 is equal to what? 0. Does that mean x2 equal to 0? Now the this x is a non-zero vector. That means you don't need to get the zeros as what? As the eigenvalue. Not all the eigenvalues should be what? Not all the values of what? The variable should be what? Should be 0. Now, since your vector is a non-zero vector, now look here. You can see s3, x1, x1. And then we have x1, x2, x3. There's one variable that is absent here, which is what? The s2. It is that s2 that we have to take as the free variable. Okay. If x is taken as what? K. So when k is equal to 1, that means x2 will be what? Will be 1. So if it is s3 that is absent, you take what? s3 as what? As k. So that means the eigenvector when lambda is equal to 1 will be x1, s2, s3. So the x1 is 0, s2 is 1, and s3 is what? 0. Now also, we do the eigenvector when lambda is 3. So when lambda is 3 now, that's 1 minus 3 minus 2 is 0, 2. 1 minus 3 minus 2 is 0. That's 2, 0 minus 3. Is x1, s2, s3 is 0, 0, 0. So let's try to reduce this matrix. So if I divide my row 1 by minus 2, that gives 1, 0 minus 1, 2 minus 2, 0, 2, 0 minus 3. And this is x1, x2, s3. That's 0, 0, 0. So that's 1 minus 3 is minus 2, 0, 2. 2, 1 minus 3 is minus 2, 0, 2, 0, minus 3. So that's 1 divided by minus 1, minus 2, that's minus 1. That's 1, 0, minus 1, 2, minus 2, 0, 2 is 0, 3. S3. So how do we turn this 2 to 0? So now this 2 to 0, that means R2 becomes R2 minus 2R1, and R3 becomes R2 minus 3R1. R3 minus 2R1. So that gives 1, 0 minus 1, 2 minus 2 times 1 is 0. Minus 2 is 0 minus 2 times minus 1 is 0 minus 2 times minus 1, that's 2. 2 minus, that's 0, 0. Minus 3, no, that's 0, 2 minus 2 times, okay, that's 0, 0. Minus 3 minus, that's R3 becomes, okay, it should be R3. R3 minus, R3 becomes R3 minus 2R1. So 0 minus, that's 0. Minus 3 minus 2 times minus 1, that's minus 3 plus 2, that's minus 1. So that's x1, s2, s3. That's 0, 0, 0. So divide this one by minus 2 to get 1 here. That's 1, 0 minus 1. That means R2 over what? Minus 2. So 1, 0, 1, 0 minus 0, 1 minus 1, 0, 0 minus 1. x1, s2, s3 equal to 0, 0, 0. So here we do not get 0 at the end. So let's check our matrix again. That's 1 minus lambda. 1 minus 3 minus 2 is 0, 2, 2. 1 minus lambda. 1 minus 3 minus 2 is 0, 2 is 0. 1 minus lambda, that's minus 2. So it is minus 2, not minus 3. So R3 minus, so that's minus 2 minus 2R1. Minus 2 minus 2 times minus 1, that's minus 2 plus 2, that's what? 0. You should get 0 whenever we do it. There should be 0 here instead. So that's 0 minus 2. R2 minus, that's 0, then that's 2. So now, this is 1, 0 minus 1, 0, 1 minus 1. And everything else should be what? 0. So, how about the x1, s2, s3? That's x1 minus s3 equal to 0. S2 minus S3 equal to what? 0. So x1 and S2 are the pivots. S3, that's the free variable, can take any value. Let S3 be k, so S2 becomes what? Minus S2 becomes S3, that's S2 is equal to what? K. Now what about x1? x1 becomes S3 too. S3 is what? x1 is what? Is also what? It's okay. So the corresponding eigenvector of lambda equal to 3, the last one, is x1, S2, S3. That's k, bring k outside, that's 1, 1, 1. So when lambda, or when we take the value of k, should be minus, or it should be 1 rather. So that means the eigenvector is 1, 1, 1. Thank you for listening.